Your AWS Cognito setup is complete, but how do you actually test that your FastMCP server is properly secured with real user authentication? We'll walk through a complete client implementation that triggers the OAuth flow, handles the browser-based login, and verifies the protected endpoint works as expected. You'll see exactly how the token claims are exposed and how to validate user groups in your tools. From FastMCP Import Client. Import Asyncio. Async def main. Hash the client will automatically handle AWS Cognito OAuth. Async with client. http://localhost 8000/MCP auth equals OAuth as client. Hash first-time connection will open AWS Cognito login in your browser. Print authenticated with AWS Cognito. Hash test the protected tool. Print calling protected tool. Get access token claims. Result equals await client. Call tool. Get access token claims. User data equals result data. Print available access token claims. Print f sub. User data get sub. NA. Print f username. User data get username. NA. Print f cognito groups. User data get cognito groups. If name equals main. Asyncio run main. This demonstrates the OAuth proxy pattern for integrating traditional OAuth providers with modern RPC frameworks. The pattern bridges systems that don't natively support dynamic client registration, like AWS Cognito, with frameworks that require it, like FastMCP. What makes this distinctive is its ability to maintain standard OAuth flows while adapting to framework-specific authentication requirements. The approach works by handling the OAuth dance externally, then injecting the resulting JWT tokens into the framework's authentication layer. The client library manages browser-based login flows and token caching transparently, while the server validates tokens against the provider's public keys. This separation keeps authentication logic cleanly isolated from business logic, following the principle of separation of concerns. This pattern matters because it enables enterprise-grade authentication without sacrificing developer experience. You get AWS Cognito's robust identity management, including SSO, MFA, and group-based access control, while writing minimal authentication code. The trade-off is slightly more complex initial setup compared to simpler auth methods, but the result is production-ready security with minimal ongoing maintenance. Let's break it down line by line. From FastMCP Import Client. Imports the client class from FastMCP, the primary interface for connecting to MCP servers. This handles low-level connection management, authentication, and tool invocation with a clean Async API. Import Asyncio. Imports Python's built-in Asyncio library, which enables asynchronous I/O operations. This is required for the async await syntax used throughout the script and allows non-blocking network calls to the MCP server. Async def main. Defines the async entry point for the script. This is the coroutine that will be executed by the Asyncio event loop, enabling all asynchronous operations like the OAuth flow and MCP client calls. The async def syntax is required because we're working with async await patterns for non-blocking I/O. Hash the client will automatically handle AWS Cognito OAuth. Async with client http://localhost 8000/MCP auth equals OAuth as client. This establishes an authenticated connection using FastMCP's context manager pattern. The auth equals OAuth parameter triggers automatic AWS Cognito OAuth flow, handling the browser login and token exchange behind the scenes. Context Manager ensures proper connection cleanup when the block exits, preventing resource leaks.
Hash first-time connection will open AWS Cognito login in your browser. Print authenticated with AWS Cognito.
This print statement confirms successful AWS Cognito authentication. The first connection triggers an OAuth flow in your default browser, and this message verifies the handshake completed before proceeding with protected operations. It's a simple but critical checkpoint in the auth workflow.
Hash test the protected tool. Print calling protected tool. Get access token claims.
This logs the tool invocation to SDDout, confirming we're testing the protected get access token claims endpoint. The print statement serves as both a progress indicator and verification that the OAuth flow completed successfully before making the protected call.
Result equals await client, call tool, get access token claims.
This invokes the protected get access token claims tool via FastMCP's RPC system. The await handles the async response, returning the decoded JWT claims from AWS Cognito for user identity verification. This pattern is how you securely access authenticated user data in FastMCP workflows.
User data equals result data.
This extracts the tool response data from the result object. FastMCP wraps all tool outputs in a standardized result container, so accessing data gives you the raw JSON payload returned by the server.
Print available access token claims.
This header announces the output section for JWT token claims. It clearly separates the authentication metadata from other output, making it easier to verify user attributes like group memberships and user IDs in the debug output.
Print f sub, user data get sub, NA.
This uses the dictionary get method with a fallback value. It safely retrieves the subclaim from the JWT token, returning NA if the key doesn't exist, preventing key error exceptions. This defensive pattern is critical when handling external identity provider data where claim availability isn't guaranteed.
Print f username, user data get username, NA.
This uses get with a fallback value to safely access the username claim. Prevents key error if the claim is missing, returning NA instead, which is critical for handling incomplete or unexpected JWT payloads.
Print f Cognito groups, user data get Cognito groups.
This prints the user's Cognito group memberships from the access token claims. The empty list fallback handles cases where the user has no group assignments, preventing key error exceptions. This pattern ensures safe dictionary access when dealing with optional JWT claims.
If name equals main.
Python's standard entry point guard prevents the async event loop from launching when this module is imported elsewhere, ensuring the script only executes when run directly. Critical for reusable modules that contain both library code and executable logic.
Asyncio, run main.
This executes the async main function by starting Python's event loop. Required for running async code from synchronous entry points like scripts, it handles the async sync boundary cleanly. Without this, the coroutine would never execute. AWS Cognito integration pattern. The client handles OAuth flows automatically, abstracting AWS Cognito's complexity behind a simple auth equals OAuth parameter, while the server validates tokens through Cognito-specific claim filtering. The client's first connection always triggers a browser-based login, which can surprise developers testing headless environments. This pattern turns enterprise-grade authentication into a single configuration step.
The client that knows nothing about authentication becomes the most secure.